We learned in the last section all about how to evaluate roots, okay? Here, we're gonna take that a little bit further. So if you have something like this, the square root of x, all right, you could rewrite that as x to the power of 1/2. Okay, so how does that work? Remember when you have the square root, here you've got your index, and if it's a square root, the index is 2, right? What you can do is you can write a root in power form, in exponent form, and what happens is you have the base, that's the base x, and you raise that to an exponent, which is a fraction. Okay, so you've got a fraction for the exponent. Now what happens is the index here becomes the denominator of that exponent. The power here becomes the numerator. All right? So, and with that, you could go backwards and forwards. So for example, if you have 4 to the power of 2/3, right? The denominator is always the index. The numerator is always going to stay as an exponent. So we can rewrite this as a root. The main number, the base, goes inside the root. The denominator is always index. It goes in that little pocket. The exponent is the numerator. It becomes an exponent of the 2. Okay? All right. So let's take a look at some examples here. If you have a number to the power of 1/3, then you can write that in root form, and it'll be the cube root of 27, and that we could evaluate, right? What's a number that you could multiply by itself 3 times and get 27, and it's 3. All right. Same thing with this one. Now I have -16 to the power of 1/2. Well, when I do my root, this 2 becomes the index, so that's just square root of -16, which will then become 4i. Okay, so let's write these in radical form. I have a fractional exponent. It needs to be converted to a radical form. What's the index going to be? 5. And inside I have a. All right, here. What's the index going to be? The denominator. 4. And then it'll be d to the 7. Now.
You put the 7 in.
Okay, so both. You can put the 7 in there, or you could do 4th root of d to the 7. These are the same. And which one do you choose? You know, it really depends on the problem that you're doing. If it's something that, you know, you could take the 4th root easier and then do that, it just, which one's easier for you? Okay, so what about this one? Can we write this in exponential form? Okay, so c to the power of what? 1/8. What about this one? C to the power of -5/3. Now, am I allowed to leave it that way? No, because I'm not allowed to have negative exponents. So if I have a negative exponent, it has to be 1/c to the what now? 5/3, positive 5/3. Okay? All right, so how do we evaluate these? Basically, this one, I have a negative exponent again, which is not cool. So I'm going to change that to a positive exponent. It has to be 1/49 to the power of what? Positive 1/2. And now that is 1/the square root of 49. So that is 1/7. Now, This is a completely acceptable, what do you call it, like progression of work, okay, like totally fine. If eventually you're like, you know what, I get it, exponent of a half is just the square root, I could do this without this step, fine, I'm totally cool with that, okay? So whether you want to write this or not, it's fine, but do switch it to this first. Okay, here I have a positive exponent, so that's good. Now I've got a root. 32 goes in here. What's the index? 5. And then where does the 2 go? Either inside or outside. So I could do this. Okay? I could do this. And now I have to do 32 squared and then 5th root of that. Or if I do this and put the 2 outside, huh? This one? This one? Yeah. Yeah, this is what I would prefer for this particular problem. Because what's 5th root of 32? He says 2. Does anybody disagree? You know, how would you do it? What would you do if you didn't know? Not calculator, factor tree. So 32 is 2 and 16, right? Oh, yeah. Which is 4 and 4, 2, 2, 2, 2. Now, I need a 5th root, so I need to group these 2's by 5's, okay? So 1, 2, 3, 4, 5. They all come out as a single 2. So that's going to be 2 to the power of 2, which is 4. Okay? Questions? All right. Let's do this one. Okay, so look. Same base, different exponents. What do we do? Multiply or add? Add the exponents. So this is going to be y to the power of 1 over 7, 4 over 7. Okay, so together that's y 5 over 7. Okay. All right, what about this one? 1 over x to the power of either. So if you were to put it in root form, it'll be 7 7th root of y to the 5. Either is fine here. Okay? Either is fine. I'll let you know what you cannot do. Like in this problem here. 1 over x to the power of 2 over 3. Okay. So you are not allowed to have fractional exponents in the denominator. You know, okay, so why is that? Because if I were to write this like this, okay, look, now I have a root in the denominator, which is not cool. So what am I going to do? You have to rationalize this one, right? So I'm going to have to multiply by a cube root of something. All right, what's the something? What? X or x squared? X. Okay, why x? This is a cube root. I need a total of 3. I need a total of 3 x's. I already have 2 in the purple. I need 1 more. Okay? 1 more. 1 more. So now I have cube root of x over just x. Okay. So rule of thumb. Okay, rule of thumb. Do you leave it in root form or exponent form? Okay, let's all, it's really preference. Let's all agree on this though, for our class. Let's agree on this. If originally the problem was in exponent form, why don't we leave the answer in exponent form? That way we don't have to, ask each other. And then if a problem was in root form, we'll leave it in root form. So this one, let's leave it in exponent form. So that'll be x to the power of 1 over 3 over x.
Can you read that way now?
Yeah.
So we get flexible.
No.
Why is that x on the top?
Huh? Yeah, I was simplifying. Okay, now. Okay, that same problem, right? I'm going to show you something else. And eventually that's what I want us to do. Okay, so what I'm going to do is I'm just going to erase this part for a minute to make room for myself. Okay, so what did we have here? We had x to the negative 2 over 3. So I'm going to show you a second way to do it. So we said that this was 1 over x to the 2/3. You know this whole rationalizing bit? So the thing is, I said you can't have a fractional exponent in the denominator, right? Now, this is an x to the 2 over 3. I need to make that x to the 3 over 3, okay? So what I can do is multiply by x to the something over something. So it's 2/3. What else do I need to make it 3/3? What do I need? 1/3. And I multiply this by x to the 1/3. So now I have x to the 1/3. Here I have x to the 3 over 3, which is just x. So I have x to the 1 over 3 over x. Okay? Which is what we got before. A lot cleaner, and you don't have to keep switching back and forth. Okay? All right. So let's do this one here. Okay, this one, so again, if it's in roots, we can work in roots. So we need to rationalize this 2 here, right? So how are we going to do this? Yeah. Multiply it by, right? 2 cube root of 2 squared. Okay, because I need three 2's. I already have 1, I need 2 more. So I'm going to multiply this by the same. What do I get on the bottom? 2. Okay, here I've got a 6th root, cube root. You know what? Why don't we write these in exponent form? Can we do that? Let's do 16 to the power of 1 over 6. And let's do 2 to the power of 2 over 3. All right. So now, I have a 2 on the bottom. Take a look at that 16. Everything else has a base of 2. Can I write the 16 as a base of 2? What is 16? Is it 2 to the power of something? It's 2 to the power of 4. So can I write this as 2 to the power of 4? Right? To the power of 1 over 6. So I had 16 to the power of 1 over 6. The 16, though, is 2 to the 4. Okay? Times 2 2/3. So now what do I have here? How much is the 4 and the 1/6 going to give me? This is 4 over 1. So that's 2 to the power of 2/3 times 2 to the power of 2/3 over 2. Is that right? Is it? Okay, let's think about that. So now I have 2 to the 4/3 over 2. Right? Okay, so what happens there? How do I simplify a 2 to the something on top, 2 to the something on the bottom? What happens to those exponents? Huh? If I have 2 to the something, and what's the exponent here? 1, right? So how can I simplify those? 2 to the what? Okay, so if I have 2 to the 5 over 2 cubed, how much is that? What do I do to the exponents? I subtract the exponents, right? So here I'm going to subtract the exponents. So how much is that? 2 to the 1/3. Yeah. Yeah. Okay, so this one. Okay, so to simplify this, again, it's easier to write in terms of exponents. So I have 4x to the 4 to the power of 1/6. Okay? Now, always try to get these numbers, these coefficients, in terms of their most elemental base. So what is 4 made of? 2. It's actually 2 squared, right? X to the 4 to the power of 1/6. Now, who does that 1/6 belong to? Everybody. So this is, yeah, so yeah, right, like the base. So this is 2 squared times 1/6, so it's 2 to the 2/6, right? Should I add another step there? It's 2 squared times 1/6, and then x to the 4 times 1/6. So it's 2 to the 1/3, x to the 2/3. Okay? Now, can we put it back in root form? This is cube root of 2 and cube root of x squared. Well, what is that together? Cube root of 2x squared. Okay? Yeah, sorry. I was just looking at the chart on the bottom. Okay. All right. So with these are similar to what we did here. You see how in this problem C, we had root x plus 1 and we multiplied by the conjugate? Well, look at what I have here. I have y to the half minus 1. Is that the same as root y minus 1? Right? So what would I multiply with? The conjugate, which is root y plus 1. In this case, y to the half plus 1. So let's multiply y to the half plus 1, y to the half plus 1. Okay? All right. So what happens on the bottom? Look. Yeah, tell me. Does it cancel it completely? What do I have? Yeah. Right, look at this. I have a minus b, a plus b, right? So I need to square the first, square the last, put a minus in the middle. So if I square this one, what do I get? Y minus 1, not to the 1/4, because if I square it like this, it'll be y to the 2/2, so it's y to the 1. The numerator, I have to distribute, right? So FOIL. So here I get y to the half times y to the half is y to the what? So it's y to the, okay, let's see. Y to the half times y to the half is y to the 1/2 plus 1/2. So it's y to the 1. No, you don't have to write it. So here I'll just put y. So look, if you're multiplying these two, you add the exponent. Half plus half is an exponent of 1. Now, y to the half times 1 is plus y to the half. 1 times y to the half is plus y to the 1/2 plus 1. So this is y plus, how many of these do I have? So it's 2y to the half plus 1 over y minus 1. Huh? Okay, so how do we know if you're done? Okay, basically you're not allowed to have negative exponents. Do you have any negative exponents? No. Do you have any fractional exponents in the denominator? No. And then in the top, all of the exponents they should not be improper fractions. So 4/3 doesn't work, but 3/4 will work. Okay, what about here? These are being multiplied, so I need to rationalize these, okay? I have c to the 1/2 on the bottom. I need to make it c to the 1. So what exponent should I add? It should be half plus something else to make it a 1. So another half, right? So I multiply by c to the 1/2. Well, what about the b? What can I multiply it with? B to the 2/3. And I do the same thing on top. Okay, so why am I doing that? Because I need to do 1/3 plus something over 3 to make it 3/3, 1. 1/2 plus something over 2 to make it 2/2, 1. So now, look at what I have. On the bottom, I get C and B. What do I have on top? B to the how much? B to the 3rd times B to the 2/3. C times C to the 1/2. Can I cancel anything out? Yes, no? I can cancel out the C and the C. How about the B's? 1B here, 1B there. So what do I have? Yeah. So now what do I have? Let me just write down everything I have. I have B, B to the 2/3, C to the 1/2. How much are these together now? If that's B to the 1.
Well, how do we get B? Wouldn't it be squared?
Oh my God, it's B squared. I'm so sorry. See, man, past 12, I'm just hungry, and I could barely add. Okay, so how many total B's? What do I do to the exponents? Add them. It was B to the 3rd, and then there was a B here. So here, 2 plus 2/3, that's 8/3. C to the 1/2. This 2, I had B cubed here, and then 1B here. Yeah, okay. All right, so just a sec. So I'll address that in a minute. Okay, so how do you know that you're done? These are the conditions. Basically, you know that it's simplified when there are no negative exponents, okay? There are, You know you're done when you have no exponents that are not positive integers in the denominator. So you can't have any fractional exponents in the denominator. It can't be a complex fraction. So you can't have like c divided by 2 divided by 3. And the index is the least number possible. So that's how you know you're done. All right? As far as the improper fractions, if they're in the numerator, it's okay. In the denominator, we don't want any fractions. All right? So this is your homework. So this homework will be due Tuesday. Oops. Due Tuesday. And let's remove 59. Don't do that one. All right? Cool.